Hello, we are going to look at the tangent function today. So if we think about tangent, we know that we can get the values for tangent from the unit circle because the tan of theta equals the sine of theta divided by the cosine of theta. So we're going to first of all do a table of values and then plot those points on a graph. So I've got our graph set up for us. So if we think about the unit circle and 0, we know that, so it'd be nice to have a unit circle here, wouldn't it? Okay. We know that we're looking at this position here, and so we have the ordered pair 1, 0. So sine over cos will be 0 over 1, which will be 0. So we have this point here on our graph. All right, the next point we're going to look at is pi over 4. And we know that that's root 2 over 2, root 2 over 2. So if we take sine over cos, root 2 over 2 divided by root 2 over 2, that's going to equal 1. So pi over 4, which is halfway between 0 and pi over 2, will be at 1. So that's a good point for us to know. Pi over 2 then is 0, 1. So 1 divided by 0 is actually undefined. All right, so this is what happens on a graph if we have something undefined. There is an asymptote, and that will create a vertical asymptote right here at x equals pi over 2. That's the equation of that asymptote. Okay, 3 pi over 4. This will be negative root 2 over 2 and root 2 over 2. When we do that, we'll get negative 1. So 3 pi over 4 would be here, negative 1. Pi, negative 1, 0. So we'll have 0 over negative 1. That is 0. 5 pi over 4. They're both negative root 2 over 2, which will create a positive 1. So that'll be here, positive 1. And 3 pi over 2 down here will be 0, negative 1, which will be negative 1 divided by 0, which again is undefined. That will create another asymptote here going through x equals 3 pi over 2. Okay, the rest of the way around the circle, we have 7 pi over 4, which is here. It's going to be root 2 over 2 and negative root 2 over 2. So that will create a negative 1 again. So 7 pi over 4, negative 1. And 2 pi will bring us back around to here, the same as 0. So we will have 0. All right. Now, what happens with asymptotes? We know from exponential functions that with asymptotes, turn that light off. I think you can see better now. Sorry about that. With asymptotes, we approach the asymptote, but never touch it and never cross it. So what actually happens with this graph is here from pi over 2 to 3 pi over 2 is a good place to look for a whole period within the bounds of 2 asymptotes. So it's going to approach this asymptote coming down here. It's going to come up, a nice smooth curve, go across here, and then approach this other asymptote. So if I'm just going to turn it around this way because the basic shape of this, I'm not going through here, but if this is pi over 2, let's make it bigger. Let's say this is pi over 2, and then pi here. So if we have an asymptote here, and we have another pi over here, another asymptote here at 3 pi over 2, and then the shape of this graph actually goes like this. So approaches here and approaches here. So this is the kind of shape your curve should take. It's a little harder to see that here in this space because the horizontal distance is really narrow, but it should be this kind of curve, okay? This pattern is going to repeat itself over and over in both directions. So what we need to remember for sure is where do the asymptotes happen? Okay, there's going to be, the period is only pi radians. So another asymptote will occur over here at y equals negative pi over 2. I'm going to get rid of that unit circle now so we can see more of the graph. Okay, so we can see there's another asymptote here at x equals negative pi over 2. And where do you think the next asymptote in that direction will be? Another pi units away. So we'll have another one coming down here at x equals negative 3 pi over 2. All right, and this pattern will continue. We'll have halfway in between each of the asymptotes, we'll cross the x-axis. So halfway in between the asymptotes, cross the x-axis, and then the next one will be over here. Crossing the x-axis, the next asymptote would be over here. Next asymptote will be over here on the left-hand side. And then halfway in between where it crosses the x-axis and the asymptote is 1, a value of 1 on one side and negative 1 on the other. And that is our pattern. So we end up doing this each time. If we're only graphing to here, I'll put an arrow there. Here we'll have another one here. So this curve goes up and then over. This curve goes up and then over. This curve goes up and then over. Okay, so the 5 key things you need to make sure you remember for this graph to ensure that you can create this pattern over and over and over again is for y equals tan x. You want to for sure remember that this asymptote occurs here and here. And then the 3 major points we have are these ones. So that's negative 1, negative pi over 4. Okay, that's that point right there. Negative pi over 4, negative 1. X coordinate goes first. 0, 0, and pi over 4, 1. Okay, so those are the 3 major points and the 2 major asymptotes that you need to remember for y equals tangent of x, no transformations in there, and then that pattern just keeps repeating. So therefore the period of a tangent function is pi. Okay, the amplitude of a tangent function is undefined. We do not say that there's an amplitude here. We call that amplitude undefined because amplitude means the distance from the principal axis to the top of the wave or to the bottom of the wave. There we have the tangent function.